Hey everyone, I'm going to show you how to set up a brand new project, brand new smart contract, and deploy to a local Harmony node in a very short, hopefully short video here. So I'm in the HRC repo, which is where we keep all the token examples. Here it is on GitHub, and I'm going to make a directory for my new project. And because I'm going to work on a naming contract where you can name your address, I'm going to give it a fun name. I haven't thought of this ahead of time, so I'll just call it name service. So I'm going to go into that directory. Now, because Harmony works with Truffle as well, using Truffle deploy and migrations, and even for testing, because it's just an Ethereum smart contract written in Solidity, we can just do Truffle init inside this folder. So it's going to download a very bare bones Truffle example, which we can see right here, and we can see name service has been added to my project directory. So we can't really do anything. There's no contract, and there's no tests that are going to run. But we can borrow a lot of the code that is in the HRC repo already. So, for example, we could go get like a basic token contract. We could go get a basic this basic Faucet contract. So what I'm going to do is I'm probably just going to look under the contracts folder, see that there's no contract there. I'll make a new file and I'll call it name service. You have to kind of follow these conventions for the capital letters. It's like Pascal case. I'm not really sure why, but that's sort of a Solidity issue. And I'm going to go into the Faucet here, look at the contracts, take a look at this Faucet contract. It's very basic. There is some import of the ownership. I'll probably get rid of that, but I'm just looking over, and it's got sort of the basic sort of functionality that I need. So I'm going to copy that. I'm going to paste that in here, and I'm going to rename. First thing, rename your contract. Make sure it's the right one. Get rid of that ownable, like I said I was going to do. Get rid of that, and then I'm probably going to kill a lot of these variables. Just keep a few of the basic things. Don't make the constructor payable. That would be silly. And get rid of those functions there. So that's sort of a bare bones name service contract. It's got some mapping there, address to something. But what I'm going to do is I'm going to map it to a string. I actually think I want to make that a bytes 32 instead. I'm probably gonna have to Google some stuff about the conversion from a string to bytes 32, etc., and back. So I'll just call this names, and then just make sure everything else looks okay. It looks fine. I can probably test that this contract gets deployed already. So under test, you'll see we don't have any files, so I will make a file now, and I'll call it name service test.js. And again, I'm going to borrow from the node Faucet directory. I'm going to just borrow from the Faucet test JavaScript file here because it's already set up the way that I like it for tests. So I'm just going to copy that as sort of a boilerplate to get started. And I'm going to get rid of some of these tests. I'm going to leave a few of these things. I'm going to say that this is now lowercase name service. So this is going to be the instance of my contract, name service, name service. A lot of renaming going on. I'll probably import the gas limit, gas price. Well, no, don't worry about that now. Let's make sure that that's there. That's checking that, and get rid of all those Faucet references. We can actually just, for now, comment out all that. Okay, so we're probably going to want to name that properly and look through all that, and that looks good. Now I can do Truffle test, but the problem is that the contracts have not actually been deployed because I haven't specified any sort of migration. So yet again, I'm going to grab the migrations from the node faucet example because it's very basic. This is all just really boilerplate code to get started. So I'm going to make a deploy.js in my migrations folder. So these run in order, 1, 2, 3, blah blah blah. Again, this is more Truffle, Solidity, etc. like tooling nonsense than it is writing smart contracts or having fun or doing anything. So don't worry about that. And that whirring noise is just my laptop taking off like a rocket ship because I'm screen recording. So I'm going to name the service here, and I'm going to deploy this contract here. Not going to worry too much about the parameters. The constructor doesn't take anything, and then you get out, this name service variable in the deployment. I mean, you can log it out if you want, but probably won't. We'll skip that part. Okay, so that's the deployment. So now we have, let's quickly recap. We have name service, which is our new contract. It's pretty empty. It doesn't really do anything. We have name service, name-service.test.js. Under our test directory, we have the contract is being deployed. So let's cross our fingers and call Truffle test one more time and see if we did in fact get the contract deployed. So we can see contract name service should be deployed, check mark, it's passing. So everybody's happy. Okay. So now we have to think about how we would actually make our name service contract. So I've already kind of started here mapping an address to a names sort of variable to bytes 32. I'm probably going to make that, I'll probably just make that public. And one other thing I'm going to do is we need to keep track of the names that are already occupied. So I could map bytes 32 to a Boolean, or I could just map it to an address. Pretty sure a storage operation is going to be the same thing, so it doesn't really matter. So this would just, a bytes 32 mapping to anything that isn't a 0 address would mean that it's occupied. So we can just call that affectionately addresses to kind of look up the other way. So one way gives, when a user provides an address, we get a name out. And then the other way, when a user tries to claim a new name, of type bytes 32, we can provide the owner, so we can feed in a name, get the owner, but we can also block any additional name claims. So let's just pass the constructor for now, and let's do a simple function for setting the name. So actually, we already know the address coming in, so really all we need to know is bytes 32, the name, and let's make this public. Let's not return anything for now, and let's just say names at, and then this is just sort of a little solidity inside. We know that the sending sort of payload of any contract transaction has a sender variable, so we're just gonna queue that up. We're gonna say message.sender. And this is a mapping, so we have to have that equal some bytes 32, so we'll set that to name. Not sure yet if I'll have to actually pass in a string as a parameter and then convert that to like a SHA-256 hash and then store it here, but we'll tackle that when we get to it. We'll probably get some errors and stuff, and then we'll just debug it. So names, message.sender equals name, sounds good, okay, and then addresses at name equals, let's change that actually, that's a bit of a misnomer now. So an address can look up the name and the mapping of names. Let's call that owners, So owners of a particular name, well, you know, we don't get back like a human name, we get back an address because that's the owner, right? So we'll just say that is message.sender. So yeah, unfortunately there's two write operations here. Little unfortunate, but it's probably the best way to just kind of naively bulletproof this system for now. Probably want, we do have this variable declared as public. Would be nice to declare like an explicit public getter if we have to do any conversion here from string to SHA-256 hash within the contract. So let's just do, I think it's public view returns, and we're going to get the name for a given address. So we're going to return bytes 32, and this means also, of course, that all names have to be 32 characters in length. So we're going to return names message.sender. That looks good. We can also just make these private. So only this contract will be able to edit these or do anything or read them through sort of a public interface. So let's just say these are, you know, public interface to this contract, and this is sort of, well, this is part of the public interface too. So let's just put that there, and then we can put, you know, private methods up here if we want to later. I'm not even sure if we'll need that, but let's jump back to the test. So we really want to test. It should allow Alice to set her name. So we will say name service dot set name, and we're going to feed it some bytes 32. I really don't know if this is going to work, so I'm probably going to have to look up how Solidity deals with string to bytes 32 conversion. But let's just roll the dice, and it's going to be from Alice. Okay, and let's uncomment these accounts. I just name these accounts in my tests just to make it easy. So should allow Alice to set her name. So we're going to go ahead and we're going to await that transaction, and then we're going to say we're going to get the bytes 32 out by awaiting a name service dot get name. I think I have to change these parameters here to like a send or something, but I'll just do a call. And we're going to quickly look, double check. So get name is looking for the name at message.sender, but that's probably not what we want. I kind of messed up here. We want to pass in address who, and we'll just feed back the name. So we're going to save that. So again, address is the parameter. So get name for who, get name for Alice. And then we're just going to do a dot call, and then we're going to just log out the name so we don't know if the bytes 32 is going to come out like in hex or BL garbled or whatever. This is blockchain after all. So we want to assert that name equals, and we put in that name Alice. Let's put in let's hard code that as a variable just so our tests are easy. Alice name, Alice. Okay, and let's put that here and here. Okay, so name service set name, Alice name. Probably assuming that we need either like a dot send or something. I can't remember off the top of my head. I'll just cheat. I'll look at the Faucet test. So get balance dot call. Okay, and you can just call them directly. All right, not how most SDKs work, but don't worry about it. So we're going to do name service dot set name. We're going to await the transaction here. Set name should be done, and we're actually on to probably the next block. So we're on to the next block. Then we're going to read out the name, get name Alice dot call, and that should work. then spit out the name variable here just for sanity check, because again, we're not sure about the bytes32 format. Assert equals name equals Alice name, the name that we set. So should allow Alice to set her name. So let's give it a whirl. It's probably gonna fail, but let's check it out anyways. Invalid byte32 variable value. So again, I'm not super I'm not remembering right now how bytes32 works. So let me just take a sec to think about this. Arg name. Okay, so it didn't like this value here. So I'm gonna probably go ahead and Google that. I'll just pause for a sec. All right, so I'm back, and I actually looked this up, and I found out that there's a handy little utility function converting ASCII to hex. So I guess the value must be hex. So let's just take Alice's name and convert it up here, and that way, every time we use it, we're just converting in and out of hex. So I figured something might be amiss. Let's see if that test passes. Okay, name service.getName call is not a function. Okay, that's just me mixing the live sort of syntax here. I'm just gonna check my faucet test. .call, don't have any parameters. Oh yeah, so I have an extra sort of method call there. I think we just .call like that. It's a little bit of a different format within the Truffle test, but it's not the end of the world. Looks like the bytes32 error went away though. So what we got was we expected something to equal something, but we got back this. Yeah, that's the padding with zeros that these guys were talking about in this question. So I don't like this, but you know, whatever. This is a little bit awful, but we can do it. How many? It's gonna actually try to pad 66 positions of 0. Oh, it's going to pad the whole string with the extra 2 there. So it's 64 characters long. Oh, isn't that cute? Hey, okay, so forgot to turn back on the recording. I don't know where I stopped. I went to GitHub to figure out why I was getting the web or the bytes32 error. Found some stuff about a Web3 helper utility, ASCII. If I've covered this already, don't worry about it. Basically, the trick is to convert the variable to hex, and then that brought up another error, which is up here, where this utility converted it to hex, but it didn't pad it. So what comes back out of the contract is a fully padded 256-bit bytes32 string. So in order to make everything, happy, you have to send in all 32 bytes in the beginning. So in JavaScript, we would just pad a 64 character length. That's 64 times. I don't know why it's times 8 times 4, I guess. I don't know, 256 bits, but let's just, oh yeah, because it's Unicode, blah, 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 divide by 2. Okay, don't worry about it. But basically, we need to pad a string that's like normally 0x 64 characters long. So we can just check that out here too. Let's just print that out. And basically, let's print out the length too, actually. And let's see Alice name here. Okay, so the reason why we need to pad it is because what we put in is what we should get out, and then all the tests are going to pass. So don't worry about that. That's just like, this is like nitty gritty Solidity nonsense. I made the name a little longer too, just for fun, to try to test it. Names should be no longer than 32 characters. Not even sure what happens when we do that, but let's give it a shot. Just see. It probably is going to error. It's going to say it's like too long or something. Byte32 value, blah, 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 invalid. So it's an invalid byte32 value because it's bigger than, oh, that's why. Oh, my recording. I made my recording hotkey Control Z. That was really dumb. Don't worry about that. Okay, we're back. I changed the hotkey to Alt Z so that I don't shut off the recording again. So now we're basically should allow Alice to set her name. I'm going to copy that, and I'm going to put a new test down here. Should allow anyone, doesn't really matter, to find Alice's address by name. So we are going to get the owner, and we're going to pass in Alice name. This is a call, though, just reading data from the contract. We don't really care who sends it. We just want to get the name, the address. So let's just call it address. And let's just assert that the address equals Alice's address. So this is a quick one. And let's just Truffle test that. Okay, we have an error here. Whoops. Okay, just a little typo. Awesome. Okay, so we've got Alice's address. So pretty confident here in the contract so far. So once you're sort of at this stage, you probably want to deploy the contract to your front end, and that's where we'll sort of stop this part of the tutorial. So it'll wrap up pretty quick here. Under node faucet, you'll also see I've got like a .m file. So it's got a bunch of stuff in it. Don't worry about that. It's just got like some generic like some keys and stuff that we've been using on local testnet, things like that. What I'm going to do, actually, I'm just going to copy the file, and I'm just going to paste it into the name service directory. So paste it here, and you'll notice we don't need config.js yet, but we will do a front end part of this example in part 2. You'll notice I've got a Truffle config here, and there's a lot of stuff that's configured a little bit differently than what you would normally see. So I'm going to actually copy that, and in the name service Truffle config up here, it's really bare bones. So I'm just going to delete it, and I'm going to paste in the one from the node faucet example. So just like, don't worry about all the extra stuff here. You'll also need the .m file, so I'm going to copy that. I shouldn't copy the package.json. I should just npm here, init something, and I'm going to import .env. So it's going to should add package.json to my project here. I don't know where it is, but let's see. Let's just close some of these tabs here. So what we're going to do is we're just going to try to set up this Truffle config here. I mean, if I try to migrate local right now, it's not going to work. It's going to complain with some sort of errors because it doesn't have certain libraries. So it can't find harmony.js core. So we have to import harmony.js core. think I really want to make sure this is set up right. Yeah. Yeah, this looks good. So we should have .env as a dependency. Let's just reinstall that. Hopefully this shows up. It should be under there. Yeah, that's good. And not sure if we need any other dependencies right now, since we're just going to try to deploy. So we're going to try to deploy, and here in Truffle config, you'll see that we have a local network. And what's it complaining about now? TSLib. Oh yeah, right. So Harmony Core. I'm just gonna be really lazy and install that TSLib. Harmony Core is all written in TypeScript, so it just needs that to compile and everything. So it looks like it's going now. So it's gonna run a dry run. This is just Truffle working behind the scenes. It's going to run a dry run simulation, and now it's actually deploying the migrations to my local Harmony network. I actually have a Harmony node running in a different console, so it's actually deploying to that node right now. So if we look at local, we see that it's using what URL, the local URL. If we trace that all the way back through our environment variables, we have the local URL here. So this is the actual local host. So now that that's deployed, in part 2, we will look at talking to that deployed contract on chain and actually interacting with it because it's deployed on that local host. All right, so stay tuned for part 2.